We're Team Potatoes Gonna Potate, and this is our final report for our natural language processing project. So, the goal of this project was to create two programs, an ask program and an answer program, that could take in a Wikipedia article and then either generate questions based on the article text, or in the case of the answer program, answer some input questions about the article. So our approach towards solving these problems was that simplicity is better than, complexity. We decided that we were going to use a more simple approach in order to avoid long running times and errors being compounded from passing inputs from one module to the next by using external tools. So as a result, we didn't use as many external tools. We used the Stanford tree parser, which has a high accuracy rate. We used Stanford named entity recognition module, which again also has a pretty good accuracy rate. And then we used the split A statistical sentence boundary detection in order to segment our input. So for the ask program, we decided that we were going to focus on asking two kinds of questions: easy yes or no questions, and harder questions where the answer would be an NP. And so for our easy questions, we simply search the input for forms of the verb to be, and then rearrange the sentence to generate a question where the answer was yes. For example, if we have the sentence, the dog is cute, then we would find the word is, and we would simply move is to the beginning of the sentence and ask, is the dog cute? Which the answer would then be yes. So for our harder questions, we focused on finding sentences of a specific form using the output of the Stanford tree parser. The sentences we were looking for started with an NP and didn't have too many clauses in order to keep our questions of reasonable length. So, for example, if we had the sentence, the dog chased the cat, the Stanford tree parser would identify the dog as an NP. Then we would perform named entity recognition on it in order to determine which question word, like who, what, where, etc., what we would use in order to generate our question. In this case, the correct choice should be what. So we would replace this NP with the appropriate question word, and our generated question would be what chased the cat. We found that this method was also capable of generating harder questions that would require co-reference resolution in order to solve if the chosen NP happened to be a pronoun. For example, if we had the sentence, he chased the cat, then someone who wanted to answer this question would have to figure out what he was referring to, which increases the difficulty level. So our ask program would first try to ask as many of these medium and hard questions as possible before falling back to the easy questions. And hopefully we generated challenging questions for other teams to answer. So our answering program goal was to identify keywords that we thought would be relevant and then search the document for these keywords. The way we did this was by building a unigram model of the words in the document text. Then we would compare the words in the question to the model probabilities and choose the non-common words that occurred fewest times in the article as keywords. Then we would search the article to identify a sentence with these keywords and simply return that sentence. However, because we weren't using any co-reference resolution programs, we decided that if the result sentence began with a pronoun, that we would simply return the preceding sentence as well, in hopes of capturing the antecedent of that pronoun. So in our testing, we found that both our ask and answer programs did a pretty good job of returning good results that made sense and were fluent. And so that's about it. Thanks for listening. We're Team Potatoes Gonna Potate.